So, problem set, 73. I don't know why I'm singing today. It's not good. Usually if I'm singing, that means that I'm just done. Like I'm out of it, done, it's over. It's like so over. So, yesterday's lesson was on volumes. Let's recap. What volumes did you learn? Volume of a
cylinder.
Yesterday you had a test. The day before yesterday.
Oh,
volume of a cone is what?
Oh,
1/3 pi r squared h. Okay? What's the volume of a pyramid? Area of the base times height. Why? Because we don't know what kind of base it will have. It could be a triangular pyramid where the base is a triangle. It could be a rectangular pyramid where the base is a rectangle. Rectangular pyramid, rectangle. Got it? Could be a hexagonal pyramid where there's six-sided bottom. Okay? So that's that. How do we find the surface area of these shapes? Surface area of a cone already on your quiz is pi r squared plus
Or pi, 2 pi.
no, pi r L. There we go. Okay, and surface area of a pyramid, area of the base plus lateral surface area. There's no good way to do it. Okay, so that's our recap. This marker is dying. Buckets, that one too.
Wow.
All right. I had like more good markers. Ooh, right there. Okay. Today's lesson is another equation that you have to memorize. I'm dying too. So this is called the difference of squares. And it is a formula you must know. I'm just going to hit that note card right there. Okay? Got to hit the note card. Difference of squares. If you have something squared minus something squared, you can factor that as the following. A minus b times, did you write it down? A minus b times a plus b. Remember, factoring is the opposite of distributing, so we end up with parentheses. And this is it. Perhaps you need an example. Why are you angry? Unfurl your eyebrows. Choose joy. Yes?
Okay. So how come there's an a minus b and there's an a plus b? Why are they?
Because that is what it is. If you don't believe me, let's multiply them out and distribute. Remember, factoring is the opposite of distributing. So, if I multiply this out, it should give me a squared minus b
Oh,
squared.
I see.
Oh,
Okay.
because it's being it's negative. Okay. I got you.
Yeah, I see it now. Okay, that makes sense.
There's no c in the problem. I'm sorry.
Very good, very good.
This is a squared minus b squared. Are we surprised? No, because I just told you that's what it was. Maybe I lied to you. Maybe I lie to you often. I don't know. Then maybe you should be surprised. But I try not to. So hopefully this does not surprise you. Now, there is a warning. Sir. Surprise. This does not work on a squared plus b squared. Okay? There's no way to get a squared plus b squared other than taking a and squaring it, and then taking b and squaring that. Yeah. So, no equation for a squared plus b squared, equation for a squared minus squared there, minus b squared there. So, what is your problem going to look like? Well, it might say factor this. Okay, is this in that form?
Yes. No.
I have something minus something else?
Yep.
No,
Oh, no.
minus plus.
No.
So I have to reorder them. I have x squared minus what squared?
4. 2. 2. Negative 2. No, it's 2. No. Negative 2. 2. Okay.
2.
X squared minus 4. Now, why did I write it that way? Because there's no y in the problem, I'm sorry. This is A, and this, 2, is B. So what is this going to be in factored form? Well, it will be the following. A minus b times a plus b. So now, all I'm going to do is I'm going to plug in a, which was x, and b, which was
2. 4. Not 2. Okay.
still 2. Okay, why did I use 2 instead of 4? Because b squared is 4, so b must be
2.
2. It must be.
Wow.
All right, I'll have you try on your own. Let's do a more difficult one. Okay, we know this is a difference of squares because we look, there's square powers here, so we're already thinking 49 is 7 squared. So it is something squared minus something squared. Your first step, what squared equals 49?
7.
What squared equals m squared?
M.
M, because it's m, and then we'll square that. This is minus a squared. So now factor and out of copy. Ooh, and more copy. Coffee. That's not your question, right?
Oh, no, just a
Acceptable answers are 7m minus a times 7m plus a. Or you could switch the order. That's fine too. So it could be 7m plus a times 7m minus a. Is it this? If not, it is not correct.
I put the opposite. I put a minus 7m and then not. It's not supposed to.
No, the first one has to stay the first one.
Why?
Because that's the formula.
Yeah.
Otherwise your formula doesn't work. So let's prove it out. If you did a minus 7m times a plus 7m, what would you get? A squared minus
49
or plus, what is this? 7am minus 7am plus 49m squared. That's minus. So this is a squared minus 49m squared. Is that the same as what you started with? No. So the order obviously matters. So you can't do that.
All right.
Okay, moving on. Let's try this very much more difficult problem. Not to be confused with the plant that's a ficus.
Huh?
Sometimes my jokes take a little hang time. It's because I'm an engineer.
Anytime.
How about this one? Okay, your first step is to
Factor.
go.
Wow.
You need the positive one first, the negative one second. So, your first step is to
Factor. No, switch.
switch the order. Then, your next step is to
Factor.
see what each thing is squared. So, switch the order. Switch the order. Switch the order. I'm watching. I'm standing right here. I can see if you did it or not, or if you're just like blissfully just staring off into space.
Wait, what?
Okay? Then figure out what each one is squared. So, what is 25y squared? Just take the square root. So figure out what goes in the parentheses. Then apply the formula. So I will learn the formulas. So what squared is 25? What squared is y? Plug it in there. Did you get it?
Secret. Patty formula?
Correct. Use the formula now. A minus b. So a minus b times a plus b. So it's just 5y minus 6. Okay, so the first one is 5y squared minus 6a squared. Then a minus b times a plus b. That's it.
Okay.
Done. Now, if that was our whole lesson, man, we would be very happy and have the extra time for homework. But it's not. There's more.
Wow.
So, for those of you who still did not watch the video from last Friday, go watch the video. Otherwise, you'll have no clue what we're talking about. For those of you who did watch the video, tune in because you're ready for more content. So, up to this point, you have done probability with replacement. Okay? What does that mean? Well, they put like 7 red marbles and 3 blue marbles into a bucket.
Oh yeah.
And then you pull one out. What's the probability of that being red?
21.
What are the chances of getting a red marble out? How many red marbles are there?
7.
7. How many marbles total are there?
10.
10. And assuming we have not lost our marbles, then the probability of pulling a red one out is 7 out of 10, or 70%. That's pretty good.
It's really easy.
But up to this point, they've said, okay, well, now put that marble back. And then they ask, like, what's the probability of doing a red one, taking that out, going, oh, this is red, putting it back in, and then pulling out another one. Let's say that's blue. What's the probability of pulling a red one?
70%.
7 out of 10. Now, what do? Do we add, subtract, multiply, or divide?
Divide.
Divided.
Subtract.
So we have 2 things happening in order. We're going to multiply by the probability of pulling a blue one. But I pulled the red one out and I put it back in. So how many total are there still in the urn or container? There's still 10 left, and there's 3. So it's 21 over 100. Okay, we multiply because it should go down, right? And since these are fractions, when you multiply them, it'll get smaller. Okay, but now the problems get more difficult. Are you angry? Are you angry? 1/2 times 1/2 is 1/4. So when you multiply 2 fractions less than 1, they get smaller. Right? And so this should be smaller than just pulling a red one, because you have to pull a red one, put it back, and then get a blue one. That's hard. There's only a 21% chance of that. My math teacher used to say, it makes kind of sense. She meant to say it kind of makes sense, but she said makes kind of sense. And it makes kind of sense.
Yes.
What's up?
So, how is the question formatted?
It's a word problem. It's horrible. You'll be fine.
If it says if you take one out and then.
We'll get there.
Sorry.
Thank you. Okay, now, here is our issue. This was with replacement. Okay, because you replaced the marble back. Now, you are going to get problems that ask you to do it with replacement and without. Should you get a different answer?
Yes.
If you take the red one out and keep it out, do you have better chances or worse chances of getting a blue one next time?
Oh, worse.
Better. Why? Because there's less marbles in there. Right? You've lost your marble. So it should be easier. That means we should have a higher probability if we don't put that red marble back in. Let's try it. So without replacement, the probability of getting a red marble the first time is still the same, right? There's 7 reds out of the total of 10. But we're going to multiply this by the probability of blues. How many blue marbles are in there?
3.
3, because I took out a red marble. But how many total are there?
9.
How many total, AJ?
What?
How many total? Why?
I don't know.
Don't just jump on the bandwagon. Why are there 9? Why not 10?
I don't know.
I'll figure it out. Why
Sorry,
not?
I was looking.
If I take a red marble out and don't put it back,
There's
how many
9.
marbles are there? Why?
God, there's one missing.
There's one missing, right? So, now there are only 9 marbles.
Well,
And so, the chances are 21 over 90, which is much better. Actually, not much better, but like, It's 23%. So you get like 2% more chance. Now, what if I asked, what's the probability of getting a red one and then another red one without replacement?
Oh.
Sonny, what's the probability of getting a red one the first time?
You get red.
I know, but what's the probability? I know I'm getting red. How many red marbles are there? 7. How many total? 10. So I pull a red marble. Yes! And I throw it at Jaden.
And you
it looks
miss.
like we're falling asleep. And I miss. That's right. That makes me a good teacher. If I hit him, then it's not good.
Right.
Now,
Yeah,
for the second red marble, how many red marbles are left in the container, Evan?
Six.
6. Because we removed one. How many total marbles are in there, Kara? 9. Now, if you can cancel, do so. So this is 7 over 15, which is pretty good, 47%. You're like right there. Like you got some good chances of getting that marble. Okay? So, when you have without replacement, the bottom number can change, but you also need to think about the top number. Because if you're doing the same kind of marble, the number of those marbles left will reduce. You will see the problems in your homework. It's just a long word problem.
I have a question about, so, with the probability of red and blue on the top one, how come it's not 7 over 9?
Because you're starting off with 10 marbles in there.
Oh, okay. Thank you.
Okay. And then you remove it, so then there's one. You didn't remove the marble before the problem happened. Yeah.
So it's what happens when it's not one half, or is that actually flipping?
So those are the coin ones,
Oh, they're coins.
where you flip a coin. But you're never gonna like remove coins. Like the coin flips always gonna be 1/2.
Oh, okay.
But if they want 3 heads in a row, then it's 1/2 times 1/2 times 1/2. Okay. So that's your lesson. You may begin.